Okay, so for this video, we'll be going through this question. Okay, this is actually a moments question. But let's say you don't know that this is from your notes. How would you know that this is actually a moment question? So if you read through, okay, you see that this thing is balanced, okay, and also there is this term called center of gravity. So short form is CG. Okay, so I think some of you may not have learned about CG, but center of gravity or CG is where the weight of the object seems to act in. So in this case, because this is not a uniform rod, over here it says that it is a non-uniform rod, right? So usually for a uniform object, okay, the center of gravity will be in the center. Okay, so if I have a circle, the center of gravity most likely will be in the center. So just imagine you trying to balance it, this shape on your finger. Okay, you will have to balance it in the center. So this is the center of gravity and where the weight seems to act in. But because this is an irregular object, it's non-uniform, so we will not be able to know the center of gravity just by looking at it. So we have to do some calculation. So center of gravity is linked to moments. Okay, so you have to apply the sixth step. But however, how many pivots do we have here? We have two pivots because this rod is actually supported by point X and also at point Y. Okay, two pivots. Okay, on this side, the electronic balance is reading 0.24 kg. So actually, what is the force that is weighing down on this electronic balance? So 0.24 kg, the kg will suggest that this is a reading of mass. Okay, so how do we convert it to weight? So the W equals to mg formula. So the weight will be 2.4 newtons. Okay, where your m is 0.24 and your g is 10. Alright, so multiply them together, you get 2.4 newtons. Similarly, we can do it for electronic balance at y. So again, W equals to mg, okay, equals to 0.26 multiplied by 10 equals to 2.6 newton. Okay, so the total downward force is 2.4 newton. Is 2.4 plus 2.6 newton. Okay, that means it's a total of 5 newton. Right, so if it's 5 newton, it means that the whole rod is 5 newton. Weight of whole rod is 5 newton. So to put it in a diagram, this is the rod, and I have a support point here and a support point here. So this is actually your X and Y. They are supporting it with a force of 2.4 newton. Okay, that's why the electronic balance is displaying 2.4 newton. And at Y, it is supporting it with 2.6 newton. Okay, and somewhere at the center of gravity of the rod, the total weight is 5 newton. So as you can see, total weight is 5 newton downwards. X is supporting it with 2.4 newton and Y is supporting it up with a force of 2.6 newton. So where do you think is the center of gravity? Nearer to X or nearer to Y? You think about it. Okay, which later on we can actually calculate the center of gravity to prove your guess. Okay, so my question again is, where is the center of gravity nearer to? Is it at X, nearer to Y, or right in the middle? Okay, of course right in the middle is wrong because I already told you it's a non-uniform steel rod. Okay, so let's see how we can actually solve this question. So in order to solve moments question, we need to have the sixth step. So first step is identify a pivot. So where do you want the pivot to be? Because now we actually have two pivots. Do you want it to be at X or do you want it to be at Y? Okay. So I'm going to do at X we choose X to be the pivot. Choose X to be at pivot. Choose pivot to be at X, sorry. Choose pivot to be at X. Choose X to be pivot, okay. Okay, so this is first step, choose X to be the pivot. Okay, second step, how many forces are there? There are three forces. The first one is the 2.4 Newton at X, 5 Newton, 2.4 is actually upwards, yeah, because it's the force that is acting on the rod, so it's pushing it up. 5 Newton is downwards at CG, which I don't know where's the location. Then 2.6 Newton is also upwards, is at Y. Okay, so we have these three forces, the 2.4 Newton acting upwards, 5 Newton, which is the weight of the rod, downwards, and 2.6 Newton at Y acting upwards. So this is step 2, how many forces are there? Alright, then step 3 is the most important, where is the perpendicular distance of each force to perpendicular distance of each force to pivot. So the pivot is actually at X, right? Pivot is at X. So the 2.4 Newton will actually have perpendicular distance equals to 0. Okay, because the pivot is at X and this 2.4 Newton is actually exerted at X. So the force actually passes through the pivot, so the perpendicular distance is 0. Okay. Now, how about the 5 Newton? So maybe I can let this distance be D. Okay, because we don't know where the CG is, I'm trying to find where the CG is. Is it closer to X or is it closer to Y? So I don't know the distance, but since I choose X to be the pivot, I will let this distance between the 5 Newton and the pivot to be D. So let me call it D. Okay. Then for the 2.6 Newton, the perpendicular distance is actually 1.8 meters because it is the entire length of this rod. This entire length is 1.8 meters. So this is step 3. Step 4, calculate, find moment. Okay, so for this 2.4 Newton, it is actually 0, right? Because 2.4 multiplied by anything that's 0 will become 0, right? Remember, if the force is exerted at the pivot, there is no moments because the perpendicular distance is 0. So for this 5 Newton, it is 5D, right? We take this 5 Newton multiplied by the perpendicular distance, which is D. Then this will then be 4.68 Newton meter. Okay. Next, this is after finding moment, we have to find the direction of each moment. Direction, yeah. Okay, so if X is the pivot, I must always be very clear where my pivot is. And since this 2.4 Newton multiplied by 0 gives me no moment, I do not need to find the direction because there's none. But for the 5 Newton, as this is acting on the right hand side of this pivot, it's going downwards. So use the pen trick. I will hold the a pen on the left hand side and 5 Newton is on the right hand side, and I'll press it down and it will be clockwise. Okay. Then I use the pen trick again. I hold the pivot at the extreme left end. The 2.6 is actually on the right side of it and it's going up, so it's going to be anti-clockwise. Okay, anti-clockwise. And because this thing is not moving, stationary, not rotating, we are allowed to apply principle of moment. So principle of moment states that the sum of clockwise moment about a pivot, in this case which is at X, is equal to the sum of anti-clockwise moment about the same pivot, which is also at X, right? So we can equate 5D to be 4.68. So D equals to, divided by 5, I will get 0.936 meters. Okay, so D what is the distance of center of gravity of steel rod from NX? My D is actually 0.936. So how far is it away from Y? How far is it away from Y? I will take 1.8, which is the entire length, minus 0.936. I will get a value of 0.864. That means the center of gravity is actually nearer to Y than to X. So if you think about it, if the center of gravity is towards Y, that's why the weight or the force that is needed to support this rod will be higher. Okay, I give you one extreme example. So imagine I have this tree trunk. It's very heavy and it's actually heaviest towards the end. Now if you want an easier job of carrying, if let's say there are two persons carrying this, where would you prefer to stand? At A or at B? Definitely is at A, which is actually easier, right? Because the CG is shifted more towards the right of this non-uniform tree trunk. So B would actually need to support with a larger force. Okay.